This video is designed to demonstrate how to use Stata to conduct a logistic regression analysis. And the data we're going to use comes from a study done by Wench and Podiat, where they engaged 315 college students to ask them whether they should stop or continue research that was being conducted on cats. The cats are being euthanized and their brains are being studied for different purposes. So in these contrived scenarios, they ask students, for example, whether the research should be stopped or continued when using cats for testing cosmetics, basic theory testing about brain functioning, for agricultural purposes, meat production, veterinary research, and medical research. And participants were also asked to take a ethical inventory, which measured their idealism and their relativism. So idealism would be, for example, the more idealistic a person would be, the less likely they would want the research to continue under no circumstances, regardless of the benefits to society. Whereas other people on the relativism scale, the higher the relativism scale, the more open those individuals were to using or to continuing the research if it benefits society. For example, if it would improve the health of cats, or if it would be a benefit in terms of medical research for humans. So in Stata, I've already opened the Wench and Podiat data, and so we'll just browse that. And we can see that our data is coded as decision stop or continue. Then we have the idealism score and the relativism score for each student. Then we have their gender. And then we have coded if they were told that the cats would be used for cosmetic purposes, or then we have ones in the box for theory. So these students were told that the cats were being used in the experiment for understanding brain theory and brain functioning. Then we have ones in the meat column for those students who were told they were being used for understanding meat production, and then veterinary purposes. And then we had one other column which we don't need to include because of the dummy coding, that was for medical purposes. So we're going to go ahead and run the logistic regression using Stata. And I'm going to close the spreadsheet, and I'm going to go to statistics. And the first thing I'm going to do is get a frequency table to look at the decision-making information. And so we have 59.37% who decided the experiment should be stopped, and 40.63% who decided the experiment should be continued. Okay, now I'm going to go up and run the logistic regression. I'm going to go to binary outcomes, logistic regression reporting coefficients. And so now my dependent variable is decision, of course, and then my independent variables are idealism, relativism, gender, cosmetic, theory, meat, and veterinary purposes. And then I can go submit. And so now you see that I have several important pieces of information here. First of all, my chi-square is significant, so that indicates that the model is significantly explaining decision making, whether to stop or continue the research. The pseudo R-square is 0.21. And so the pseudo R-square in this case may be interpreted as 21% of the decision making, whether to stop or continue, is explained by these independent variables, or covariates as they're called with logistic regression. However, you might want to do some more reading about interpreting pseudo R-squares because it's not quite the same as using those to interpret ordinary least squares regression. The next thing you'll see is we get our coefficients, and these are just like the beta coefficients that are presented in multiple regression. So these are unstandardized coefficients. And we can see that the significance based on the Wald statistic, idealism is significant, relativism is significant, gender, theory testing, and meat production. Those are significant contributors to explaining students' decision making. Now, one of the things that really helps us to interpret the impact of each one of these variables is what's called the odds ratio. And so to get the odds ratio, we can go back up to statistics. We can go to binary outcomes. We can go to our same dialog box, logistic regression reporting coefficients. And under reporting, we can check report odds ratios and then OK. So now you'll notice that instead of the unstandardized coefficients, we obtain the odds ratios. So in this case, let's look at how we might interpret those. So for relativism, for every 1 unit increase in the relativism score, the chance of the probability of continuing or making the decision to continue increases 1.4 times. In terms of gender, males are coded 0 and males are coded 1 and females are coded 0. So because this is a positive coefficient, what we can interpret this by saying that males are 3.5 times more likely than females to continue or to make the decision to continue. Idealism, for example, is less than 1. And so in this case, for every 1 unit change or increase in idealism, the odds or the decision to continue only increases by about 0.5 times. So not a very large influence at all in terms of an effect size or the odds ratio. Now, the other thing that is important to look at is the classification table. And we can obtain that by going to statistics, post-estimation, and then specifications, diagnostic, and goodness of fit, and then classification table with sensitivity and specificity results. And so I can launch that. Okay. And so what this does is it gives me the how individuals were classified. So this would be to continue, this would be to stop based on the model. And these were the actual proportions based on the decision to continue and based on the decision to stop. So we had 74 that were correctly classified to continue and 152 that were correctly classified to stop. These individuals were classified to continue, but they actually indicated the research should stop. These individuals are classified to discontinue, but they were actually uh, indicated that the research should continue. However, if we look at our overall hit rate, or our percentage of correctly classified cases, it's about 72%, which is very good, and it's another indicator of how good the model is. Now we have two values here, sensitivity and specificity. So our sensitivity, if we divide our 74 by 128, we get 57.81. So these are the number that were correctly classified for for continuing. And if we divide our 152 over 187, we get 81.28%. And so these were the numbers of individuals who were correctly classified to discontinue the experiment. So I hope this video has proved helpful to help you understand how to interpret, how to use Stata to conduct a logistic regression, and how to interpret that. You might want to compare your results now to what those were that were reported by Winch and Podiate.